Good morning, students. So in the last video lecture, we were discussing about complex numbers and Cauchy-Riemann conditions we discussed, and few problems related with CR conditions that we discussed already. And as I said earlier, this complex number is used in quantum mechanics most probably. Mostly we'll be using only in physics in quantum mechanics, because quantum mechanics deals with the wave function. Wave function consists of real and imaginary parts. So that's the reason that always we will go with complex numbers for any wave function which is related with any quantum particle in quantum mechanics. But also this complex number is used in calculation of center of gravity, moment of inertia of a vehicle, and for a satellite. In other areas of physics also it has been used. Especially we want to find out the trajectories of any satellite, we can use this complex number. Not only in physics, but also in chemistry also it is used. For example, when you go with disintegration, chemical reactions, and all those calculations involve complex numbers. So that's the reason that always we try to learn complex numbers in detail. So in this class we are going to discuss about complex integration. So we are going to integrate some variable using complex techniques. Okay, this is called complex integration. So consider f of z is a complex function. So yesterday we discussed with w equals f of z. So we have z equals x plus iy. So x and y, it's a variable. Suppose if it is considered with some function w equals u plus iv, where u is a function of x comma y, v is also a function of x, y, then we say that f of z is nothing but a complex function. Okay, that function depends on variables x comma y. So one is real part, another one is imaginary part. So function defined for some z on a continuous curve C. So this is your continuous curve. It's a closed curve, closed contour. People say contour. Closed curve f of z dz, which is given as, for f of z we know that u plus iv. For dz we know that dx plus I dy. So we know this integration. So we are going to find the values of 0, 0 to 1, 1. The first one stands for x-axis. The second one stands for y-axis. 0, 0, 1, 1. Look at the limits. The first 0, 1, that's for x-axis. 0, another 0, 1, that is for y-axis. X squared plus iy dz. So we are going to solve this problem using complex integration. Now the condition, the first division is given as along y equals x. Then second one is along y equals x squared. Along y equal to x implies that it's a straight line equation. Of course we know that y equals mx plus c. When c equals 0, m equals 1, we can say that it's a straight line equation. So this is a straight line equation. And y equals x squared, it's like a parabola equation. Y equals x squared is a parabola equation. Y equals x is a straight line equation. Okay, so we are going to do with two subsections. Now we'll take first one, along y equals x. Along y equals x means dy equals dx. Just take this one. You have x squared plus iy. Instead of dz, we can substitute dx plus I dy. Is it okay? Any doubt? Now we know that dy equals dx because x equals y. So you can differentiate on both sides. That will give you dy equals dx. So instead of dy, you can substitute dx. Now this integrands. So this is called the integrand. This integrand, it is in terms of x now, not in y. So we have changed here. It is in terms of x and y. Now here it is in terms of x alone. So we have taken out y because we have written y in terms of x. So look at the limits here. I have changed it into 0 to 1 alone. Here it is 0, 0, 1, 1, which includes the limits of x and y. Here x alone. The limits will have only x alone. Any doubt? Now dx plus I dy, you can pull it out. 1 plus I. Dx you can pull it out. Correct? So 1 plus I. Just pull dx out. Dx 1 plus I. So 1 plus I have written. And this term let it be like this. Any doubt? I repeat, dx plus I dx. You pull dx out. Dx is common. dx is common, you can pull it out. So that will give you 1 plus I. So 1 plus I have taken out. Dx is here. Okay, so now we can integrate easily, doesn't matter. So 1 plus I, integrating x squared will give you x cube by 3, integrating x will give you x squared by 2. Now you can substitute, very simple. So x cube by 3 plus I, x squared by 2, substitute the upper limit first, minus substitute the lower limit, you will have 1 by 3 plus I by 2, substitute the lower limit will give you 0. Is it okay? Any doubt? We are going to substitute for x as 1. So 1 cube is nothing but 1, so 1 by 3 plus I by 2. Now take the LCM now. We are going to take the LCM. So the LCM will give you 6. Here it is 2, this must be plus 3i. You are going to multiply 1 plus I with 2 plus 3i and you will get this. See here, 1 multiplied with 2 plus 3i will give you 2 plus 3i. Then I multiplied by 2 will give you 2i. I multiplied by 3i will give you minus 3i squared. So minus 3i plus 3i squared. I squared is minus 1, so minus 3. And you have 2 minus 3 will give you minus 1. 3i plus 2i will give you plus 5i. So this is the answer. This is for y equals x. For the first one. Very simple one. Now we'll go for y equals x squared. Any doubt? Using complex integration. Now we'll go for y equals x squared. So when it is so, then dy equals 2x dx. In the earlier case, y equals x, dy equals dx. Now it is dy equals 2x dx. Now you are going to substitute. Okay, so this is the given equation. We know already given equation. Instead of dy, you substitute 2x dx. Now again you pull dx out. Okay, so again you pull dx out. This time here this will be your I. So this will be 1 plus 2ix, correct? I2x. And here you can pull x squared out. So that will be 1 plus I. So 1 plus I have pulled out. This time I have pulled this term out. See, 1 plus I. So remaining term will be x squared 1 plus 2ix dx. So everything in terms of x now. Okay. So x squared, multiplying x squared inside, that will give you x squared plus 2i x cube dx. Now again, as usual, you will have to integrate. So that will give you x cube by 3, and this will be x to the power 4 by 4. And substitute the limit. You will get the answer as minus 1 plus 5 by 6. So that is your assignment. I have done already for you. See, I have already done the same thing. And here also you will have to do and just integrate. So that will give you x cube by 3, and this will be x to the power 4 by 4. Substitute the upper limit and lower limits, and you will get the answer exactly like this. So that will be your assignment. So this is for y equals x squared, correct? For the second one. Any doubt in the previous one? So now we will go for the next problem. So evaluate using complex integration. So we are going to evaluate this integral using complex integration. So as usual, as I said, so this contains x and y. Okay, this contains x and y. So you have two limits. This is for x and this is for y. And for that we are going to use parametric conversion, parametric equation. Parametric equation means x will be written in terms of some other variable like t or theta. That's called a parametric equation. Now we are going to write x as this one and y as 2t squared minus 1. So this is called a parametric equation. You are going to convert x and y in terms of either theta or in terms of t. Okay. So x equals t plus 1, y equals 2t squared minus 1. Okay. Now it's given us a straight line 1 comma minus 1. So these are all problem. It's given us 1 comma minus 1 and 2 comma 1. Now we know that the integration is given by this integral. We are going to find out the value of this integration. It's given. Instead of dz you can substitute dx plus I dy. We know that z equals x plus iy. So dz must be dx plus I dy. You can substitute here. So now along the path, first one, x equals t plus 1. X equals t plus 1. So which will give you dx equals dt. Correct? So to differentiate with respect to t, that will give you dx equals dt. Now y equals, next one is y equals 2t squared minus 1. So differentiate. So differentiating, that will give you dy equals 4t dt minus 0. So you have dy equals 4t dt. Any doubt? Now we have converted x and y in terms of t. Okay, correct. We have converted x and y in terms of t. Surely you will have to convert limits also. In terms of earlier limits, see, look at the limits, they are in terms of x. Now we have converted everything into t. We are going to convert. So we have to convert surely the limits also. So what is the limits? Is given as x equals t plus 1 as it is given. When x equal to 1, the first one, when x equal to 1. What is t? When x equal to 1, what is t? T will be 1 minus 1, which is equal to 0. Look at the term here, it is given. X equals t plus 1 is given. X equals t plus 1. When x equal to 1, look at the limit here, first limit. This is x, lower limit. So when x equal to 1, you substitute here. 1 equals t plus 1. So t equals 1 minus 1, 0. See, t equals 0. When x equal to 2, this is upper, see, upper limit. When x equal to 2, you substitute here. 2 equals t plus 1. So t equals 2 minus 1, answer is 1. Any doubt? So we have converted the limits also into 0 and 1. Is it okay? So earlier limits us in terms of x. Now the limits will be in terms of t. So parametric equation. So this equation we are going to change into now in terms of t. Okay. So instead of x you have to substitute t plus 1. Instead of y you are going to substitute 2t squared minus 1. Okay. Similarly dx in terms of dt. Similarly dy can be written as 4t dt. See, look at this equation. See, we have converted everything including the limits. 0 and 1. Look at the limits 0 to 1. We have everything we have converted. For example, just take 2x. Instead of x, you just substitute t plus 1. See here, 2t plus 1. Instead of y, you are going to substitute 2t squared minus 1. See, 2t squared minus 1. This plus 1 already exists. See, plus 1 is here. Multiplied by dx. dx can be written as dt plus I into 4 dt dt. So everything is in terms of t now. Any doubt? Okay. Now 2 multiplied by t, 2t. 2 multiplied by 1 will give you 2. This 2 plus 1, this 1. This is nothing but 3. So 2t plus 3. Any doubt? I repeat, 2 multiplied by t will be 2t. This is 2 multiplied by 1 will be 2. This 2 plus 1 will give you plus 3. This I tt squared minus 1, let it be like this, t let it be like this. Any doubt here? Now you are going to multiply this with this with this, and you are going to separate the real and imaginary parts. Okay, so because I is there, so we have to separate. After multiplication, we are going to separate every term. This is a real part and this will be your imaginary part. So you are going to multiply with first 2t plus 3. Okay, we will multiply. So 2t plus 3 multiplied by dt will give you 2t plus 3. Is it okay? Now I with I will give you I squared minus 1. So that will become a real number. So 2t squared minus 1 multiplied by 4t will give you this. Any doubt? Okay, we have taken the real part now. What is the imaginary part? We are going to multiply this term with this term, and this term with this term will give you imaginary part. Is it okay? I repeat, this term multiply this term with this term, and this term with this this term with this term will give you imaginary part. First we will multiply now. So we have we have pulled out. So 2t squared minus 1 multiplied by dt. So 2t squared minus 1 multiplied by dt. The first term is over. The second one, 2t plus 3 multiplied by 4t. So 4t, 2t plus 3. I have pulled I out. So this will be your imaginary part. This will be your real part. So we have separated now. Again we can simplify. We can simplify as 4t multiplied by 2t squared, that will give you minus 8t cube, correct? Minus 8t cube. Then rest term will be, you have, here you have 2t is here you have 4t. See, minus 40 minus 1, that will give you 4t plus 4t plus 40, 2t will be 60. See, 60. This 3 is here. Now simplify. Similarly, you can simplify this and you can write this. 4t multiplied 2t squared will be 2t will be 8t squared. 8t squared plus 2t squared will be 10t squared. That's all. Similarly, 4t multiplied by 3, that will give you 12t and see 12t. This minus 1 is here. That's all. Now it's very easy to integrate. So with respect to t, so t to the power 4 by 4, t squared by 2, t cube by 3. This will be t squared by 2. Here it will be t. Here also it will be 3t. So you have to substitute the limit and get the answer. So that will be your assignment again. Okay. Any doubt? See, this is another problem. Now problem continues. Okay. Same problem is there. The second part. Look at the problem. Straight line 1 comma minus 1 and 2 comma 1. Straight line. So probably you would have studied about the equation of a straight line, maybe in undergraduate studies. So at the time you would come across this, you would have come across this equation, y minus y1 divided by y2 minus y1, which is equal to x minus x1 divided by x2 minus x1, which is equal to t. So here this is your x1 y1, this is your x2 y2. So you have y, instead of y1 you substitute minus 1. So this will become plus 1. So y plus 1 divided by your y2 is 1 and your y1 is minus 1. So 1 plus 1, which is equal to, and your whatever your x let it be minus x1. x1 is your 1 divided by x2 is 2. Your x1 will be 1. So 2 minus 1, which is equal to 2, which is equal to t. So you can write either this or this. Probably first we will write this and this. So y plus 1 divided by 2 equals t. So which says that y equals 2t minus 1. We will take this one. So this becomes x minus 1 divided by 1 equals t. So x equals t plus 1. So as usual you will have to differentiate. So that will give you dy equals 2 dt and dx equals dt. Now we know this equation earlier as per the sum. So convert this one in terms of t. Already we know this one. We know this one. We have already converted, and substitute from 0 to 1. We will have to convert instead of x. We will have to convert into in terms of t. The limits also. So this becomes exactly 4 plus 8i. Of course, you know how to integrate. Okay, that's all. You have to separate real part and imaginary part. Then after that, you have to integrate. The answer goes 4 plus 8i for the last problem, for the second problem. Okay, again this will be your assignment. So 3 assignments we have you have to do. Okay, now we will go for very important as far as this unit is concerned, very important question. CR conditions, Cauchy-Riemann conditions. Okay, and already we studied yesterday itself. The last video lecture we discussed Cauchy-Riemann conditions. We discussed already. Can you remember? So this is your CR conditions. This is your CR conditions. Now we will solve one problem. F of z equals e power z. Whether this function, complex function, obeys CR equations or not, we are going to check. So z equals x plus iy. Where f of z we know that u plus iv, which is equal to e to the power z is given. Okay, z to the e to the power z. So instead of z, substitute x plus iy. Separately you can write e power x multiplied by e power iy. We know that e power ix is given as cos x plus I sin x. We know already. That formula probably you would have studied. So now instead of e power iy, you substitute here. So that will be cos y plus I sin y. You multiply e power x inside. So that will be e power x cos y plus e power x I sin y. You have separated real part and imaginary part. Real part is termed as taken as u and imaginary part is taken as v, And according to CR conditions, first you go with partial du by dx. Okay, so partial du by dx will give you e power x cos y itself, du by dy, so e power x minus sin y, so minus e power x sin y, dv by dx will be e power x sin y, and dv by dy will be e power x sin y, cos y. So there's a mistake here, it must be cos y. Okay, we are going to differentiate sin y into, so this will become cos y. So that's a mistake here. Okay, cos y. Now just check du by dx, e power x cos y, which is equal to dv by dy. So e power cos x. So both are equal. Similarly, you can check this term with a negative sign. So exactly it matches. So CR condition is satisfied. So f of z equals e power s, e power z obeys Cauchy-Riemann conditions. Any doubt? So there's a mistake here. You just find out. Okay. This is cos y. Cauchy's integral theorem. Okay, so earlier we discussed about Cauchy-Riemann's conditions. Now Cauchy's integral theorem we will discuss. So the integration goes in a closed curve. This is called a closed curve, or otherwise people will say this is contour. The circle is there. In the integration you have circle. So this is called closed integration. Okay, if f of z is analytic, analytic means it must be a single valued and it must be continuous. You are going to differentiate, that differentiation must be continuous. So you are going to differentiate f dash of z is continuous inside a simple closed curve C. Then this integration equal to 0. So this is Cauchy's integral theorem, this theorem. So let R be the region bound by the curve, let f of z be the given. So we know already be given by f of z equal to u plus iv. We know already any complex function can be written as f of z equals u plus iv. We know already. So z equals x plus iy. Differentiating will give you dz equals dx plus I dy. So this equation becomes exactly like this. Correct? So this equation u, which is a function of x and y, can be written as exactly f of z equal to u plus iv can be written as u of x comma y plus iv of x comma y. So this f of z dz is written as in terms of u and v as it is u plus iv dx plus id. Is it okay? Instead of dz you substitute here. Instead of f of z you substitute here. So this is, that's all, u plus iv. Instead of dz dx plus idy. That's all. So we can write this equation. This is the earlier equation. Earlier equation can be written as, now just multiply with I, that will give you u dx. Just take separate out real part and imaginary part. So that will give you u dx plus iu dy. Multiply these two, you just multiply. That will give you iv dx plus I into I, that will give you I squared. So I squared v dy. I squared is minus 1. So I have written this equation exactly like this. Now you can separately you can write real part and this will be your imaginary part and integrate. Okay, and integrate. See, you have integration with real part, you have integration with imaginary part. Okay, so again this can be written as u plus ib dx. Separately we can write plus minus v. See here minus v plus iu du. So I have written dx this side and dy that side. Okay, that's all. So this is your Cauchy's integral theorem. We have separately we have done in terms of dx and dy. So now we will solve some problems. Okay, using Cauchy's integral theorem. So we are going to solve. Okay, it's very easy to solve. Very simple ideas. We will solve 2 or 3 problems. We will come to know. So we are going to evaluate. As I said, this is contour. It's a closed curve. D is divided by z plus 4, where C is a circle. As I said, it's a closed one. So it must be a circle. And mod z is given as 2. Mod z means radius. Okay, mod z is usually considered as a length. Okay, here it is in terms of radius because it's closed circle. So mod z equal to 2 units of radius. Okay, for this closed curve, the radius is 2. Okay, 1. First thing you just remember, Then in the denominator, you just find out denominator, easy to remember, z plus 4 equals 0, you substitute. Then z equals minus 4. You think it of this side, it's very simple idea. Just take the denominator, z plus 4 equals 0, so z equals minus 4. So z equal to minus 4. Okay, second point. First I said you have to find out first the radius. Z equals mod z equal to 2, and your z will be minus 4. See, radius is 2. What about minus 4? Minus 4 will be away from minus 2. Correct? See, z mod z equal to 2. The radius will be 2. Look at the circle. Look at the circle. This is radius is 2. See, here also we have 2 and here have minus 2. And you have z equals minus 4. It is minus 4 is somewhere here. It is away from the circle. Okay, it is not inside the circle. Suppose if any point is inside the circle, only then you can find out the solution. Analytic solution will be there. It is just outside the circle. So there will be no solution. Is it okay? It is not analytic. You can find out the solution only when the points, analytic points, should be inside the circle. If it is outside, no, we can't do it. It's clear? So fz is not analytic because z equals minus 4. Minus 4 lies somewhere here. Radius is here somewhere. It plus 2 to minus 2. See, radius is somewhere here. Here the radius of the circle is 2. So which is a circle with the center 0, 0 and radius is 2. So that's the reason that this one is not analytic. Analytic means don't bother. That's all. Very simple problem. So you have to find out, you have to know only two things. One is about radius, then another one is this one. That's all. Okay. Now we'll go for another problem. Now you are going to integrate e power z divided by z plus 2y. Okay. Z minus 1 equals 1. First you have to find out the radius. What is the radius? 1 unit. This is your radius 1 unit. In the earlier case, simply z equal to 2. It means that the z minus 0. It's understood. So radius. So the center starts from 0. In the next case, z minus 1. The center starts from, see here, it is not 1, it is not 0, 0. Center starts from 1. Is it okay? I repeat. See, mod z equals 2. Okay. Center starts from exactly from the origin. Radius is 2. In the next case, z minus 1 mod is there. It is not z mod z equal to 1. It is not like that. It is z minus 1. So center starts from 1. So don't forget. Center starts from 1. Z minus 1. Suppose if it is z minus 4, center starts from 4. If it is z plus 4, center starts from minus 4. So very simple. So first you will have to check first this one, radius. Then second one, as I said, z equals minus 2y. We are going to do. So C is a circle with a center 1, 0 and radius is 1. So because this is z equals minus 2y, radius is 1 and whereas z equals minus 2y. So answer is not analytic. So you can't find out. Correct? We will find out. We will see. Z minus 1 will go with minus 2y minus 1. You just take root a square plus b square formula. Okay, for taking length you will have to do only minus 2y whole square plus 1 square. So that will be root of 4 plus 1. So that will be root 5 which is greater than 1. 1 is the radius. So we can't find out because the function which lies outside the circle. Is it okay? So z equals minus 2y lies outside the curve. So f of z is analytic on and inside C. So f dash of z is continuous and on inside C. Therefore by Cauchy's integral theorem answer is 0. So we can't find out. We can't find out means answer is 0. Now Cauchy's integral formula. So we started with the Cauchy-Riemann's condition earlier. Then second one we studied Cauchy integral theorem, and third one is Cauchy's integral formula. All are different. Okay, don't get confused. So this is Cauchy's integral formula. Earlier Cauchy's integral theorem. Now this is your Cauchy's integral formula. Okay, we are going to solve many problems using this integral formula. Okay, so again, as usual, f of z is analytic within and on a simply closed curve C. So you have a closed curve C because this is related with only closed curve. So this is your closed curve C. So f of z is analytic. Now you just take z dot is any point inside and make a circle C1 inside. I repeat, you have a z, you have a C is here, you have closed curve C, and z naught is any point inside, and you are going to make another circle with C1. And this one is nothing but your, that is the distance between z naught and z is nothing but your r. Okay, you consider. Then Cauchy's integral formula goes like this: f of z naught equals 1 divided by 2 pi I. You remember this one, closed integral. Okay, f of z divided by z minus z naught dz, where the integral is taken in the anti-clockwise direction. So integral usually be taken as here, it is anti-clockwise. Suppose you want to take clockwise direction, just insert minus I. So here we are going to take only anti-clockwise direction. Given C is a closed curve, draw a circle C1 with z naught as a center and radius is r. C1 lies inside C. Okay, and f of z divided by z minus z naught is analytic in the region between C and C1, between C and C1. By Cauchy's integral theorem, this is exactly Cauchy's integral theorem. So this is C here and this is C1. Okay, suppose you can draw many circles exactly like this, C1, C2, C3, C4. For everything you can go with Cauchy's integral formula, exactly it goes like this. So this is for C and this is for C1, and another one is for C2, C3, we can go with. So the equation of a circle, the radius will be say z minus z naught equal to r, as according to the picture. According to the figure, it says that the mod of z minus z naught equal to r. Taking into the polar coordinates, we can write this as r e power I theta. We will have to convert to, suppose this is circle, so we will have to convert this one into polar coordinates. So r e power I theta. So z equals z naught plus r e power I theta. Now differentiate with respect to theta. Z naught is constant. Okay, plus I r e power I theta. So dz will be I r e power theta d theta. Okay. Of course, theta varies from 0 to 2 pi. So this equation C1, C and C1, this earlier equation becomes, instead of f of z, so substitute z naught plus r e power I theta divided by z minus z naught. Z minus z naught is r e power I theta multiplied by dz. Dz is this one. Now cancel the similar terms. So this one and this one will get cancelled, correct? So you have f of z naught plus r e power I theta d theta. I have pulled I out. Any doubt? Let r tends to 0. Suppose let r tends to 0. Okay.